This video is about derivative function and its graph. Derivative function basically is a gradient function, and it's labeled as f prime of x or y prime or dy by dx. In other words, f prime of x is the instantaneous rate of change of a function at a point, or the slope of a tangent line or gradient of a tangent line. So remember, slope of a tangent line equals a derivative. When f prime of a equals to 0, at x equals a, it could be maximum value or minimum value or stationary inflection. When the derivative of f of x greater than 0, the f of x is increasing, the graph like this. If the first derivative is negative, it means the function is decreasing, the graph like this. Now let's look at this chart. When first derivative is negative, the graph is decreasing. If the first derivative is positive, the graph is increasing. When the first derivative equal to 0, we have 3 options: maximum, minimum, or stationary inflection. So when we talk about the first derivative, it means it's a positive or negative or 0. When first derivative is a positive, the graph of fx is increasing. When first derivative is negative, the graph of fx is decreasing. If first derivative equals to 0, there are 3 options: either maximum, minimum, or stationary inflection. Please remember this chart. You have to use the proper words to describe first derivative using positive, negative, or 0. When you talk about graph, you will see, it's increasing, decreasing, or it's a specific point, such as maximum, minimum, or stationary inflection. For example, find the intervals for f prime of x less than 0. That means we need a decreasing function. This is a decreasing. Therefore, the interval will be from -2 to 1. First, the derivative is a positive. That means it's an increasing function. So check. Yeah, here it's increasing. This is increasing. Therefore, we write down the interval. This is a negative infinity, positive infinity, because no ending points. We have negative infinity to -2. Union set from 1 to positive infinity. At what point the first derivative equal to 0? We know this is a local maximum point, local minimum, and also the horizontal inflection. Therefore, we could say at x equals to -2 and also 1 and 3, then the first derivative equals to 0. For example, check this graph. What's happening to dy by dx from a to e? Is it increasing or decreasing? Remember when you describe dy by dx using positive, negative or 0. So for A to B, that is positive because increasing. So dy by dx from B to C is negative. This is positive, here is positive. And we have this point that's equal to 0. So we can write down from A to B, dy by dx, positive. The graph is increasing. Then at B, dy by dx equal to 0 because the B is a local maximum. Then from B to C, dy by dx less than 0. The graph is decreasing. At C, dy by dx equal to 0. C is a local minimum. From C to D, dy dx greater than 0. The graph is increasing. At D, dy by dx equal to 0 because D is a stationary inflection. Then from D to E, dy by dx greater than 0. The graph is increasing. Now let's go to guided practice 1. A, B, C, D, and E are points on the curve y equals f of x. Shown in the diagram below. Describe the gradient of the curve. When you talk about gradient of the curve, that means the f prime of x. In passing from point B through C to D. The gradient of the curve at B. The gradient equals to 0. Then from B to C, since this is decreasing, therefore the derivative less than 0, we could see this gradient is negative. Then at C, the gradient equals to 0 because this is a minimum point, local minimum. And from C to D, the first derivative, that's positive because it's increasing. So we write down from C to D, the gradient is positive. And go to B, D has a coordinate A, f of A. And x coordinate at E is A plus 4, which means the y coordinate will be f of A plus 4. Write an expression for the gradient of the line segment DE. So we are looking for this slope. If you are given 2 points, the slope equals y2 minus y1, x2 minus x1. So we see this is x1, y1, x2, y2. You will have f of a plus 4 minus f of a over a plus 4 minus a. So you will get the f of a plus 4 minus f of a over 4. Let's go to guided practice 2. Given the graph of f of x, state the interval from a to L in which f of x is increasing. Increasing, you know, this is increasing. Then from here it's increasing. Therefore, you could say from B to D, then from G to L. The intervals from A to L in which f of x is decreasing. Decreasing from A to B, decreasing from D to this G. So we write down from A to B, from D to G. Look at the, see, a point that is a maximum value. That means D. A point that is a minimum value, which means B or this G. The name given to point K where the gradient is 0, that is a stationary inflection. Let's go to guided practice 3. The function f of x is given by the formula this. Evaluate f of 1. So f of 1, we just need to plug into the original function. 2, 1 to the third power minus 5, 1 squared, plus 7 times 1 minus 1. You will get 3. For B, calculate the derivative. So for the derivative, you will do the derivative for each term. Then you will get f prime of x equals, drop down minus 1, so get a 6x squared minus 10x plus 7. Then we need to evaluate f prime of 2. We need to plug 2 into this derivative function. So we have 6, 2 squared minus 10 times 2 plus 7. So get a 24 minus 20 plus 7 equals 11. You can use a graphing calculator to work this out. For D, state whether the function f of x is increasing or decreasing at x equals 2. Since this derivative equals 11 is a positive, means the function is increasing. Then for the E, the sketch graph shown below is the graph of a cubic function. Is it possible that this is the graph of function f of x above? No. Because when we get these two, you could say the graph is decreasing, which means from this graph, we know f prime of 2 is negative. But we got from here is a positive. That's why this is decreasing. That's the reason f prime of 2 is negative. State one reason for your decision. You could say at x equals 2, the graph is decreasing.